Got a question for you. You're in space on an asteroid. It's a complete mess. That does seem more controllable, but when you think about it, if you're on a really uneven surface, leaping over small boulders, big stones, might be quite sensible. The thing that worries me is what happens if it jumps and then flips itself over or lands on its side or something. But what it does to keep itself stable when it's off the ground is think like a cat. See, as a feline falls, it frantically flails its fur, well actually its legs, and Space Hopper keeps itself upright during flight by using its limbs in the same way.
Basically, as if you're standing on a small rope, right? And if you're about to fall, you're going to swing your arms to stay upright. That's exactly what it does.
So if you put a cat on the moon and dropped it, it would still be able to right itself, even though there's no air to grip against?
We could try, but I guess it should work.
Yeah, okay, let's not try it. Well, not with the cat. How on earth did you work out what it needs to do to get itself back in the right orientation, regardless of which way up it is?
That's a great question, because for a human, that's really hard to design. So what we used is reinforcement learning, a type of AI basically. So the robot learns that in simulation and figures out what actually works, which motions work to stay upright.
So you, in theory, trained, what, hundreds or thousands of virtual robots, and one of them eventually came out as getting it right, is that right?
Exactly. Nowadays you can simulate like years of experience in just a few minutes on a PC, and that's exactly what we're doing.
Simulating low gravity is hard here on Earth, so to test their control software, the team took Space Hopper on a very special day trip. You took this on a parabolic flight. You took it on the Vomit Comet.
Exactly.
How was that for you personally? I've never done it. I want to know what it's like.
It's amazing. I can highly recommend it.
Right. Okay.
Luckily for me, it wasn't the Vomit Comet. I was fine. And then experiencing that weightlessness is just an amazing feeling.
Did you have any time to pay attention to the robot, or were you just doing somersaults all the time?
No, I actually had a lot of time on the robot. Just for one small part, I could go and do some somersaults, but otherwise we were just operating the system.
And the system performed very well indeed. And in fact, now the team has parked the asteroid investigation plan and answered a call slightly closer to home. It's been selected by the European Space Agency ESA as a contender to go to the moon. The team suggested kitting out the robot with ground-penetrating radar to probe below the lunar surface and look for lava tubes, subsurface tunnels like the one recently discovered on a rocky plain called Mare Tranquillitatis, and which might one day be used as lunar bases to shelter humans from solar radiation up above. And lo, Space Hopper has become Lunar Leaper.
Our goal would be to land on the surface, outside of where we think that lava tube is, and then approach what is basically a big hole in the ground. It's called a lunar pit. Lunar pits are these steep-walled holes that are collapse features. So this lava tube has collapsed in the center or so. So we would want to approach this hole and look at this entry in a lot of detail. Map it in as much detail as we can, and basically also prepare for follow-up missions that might be much bigger, much more expensive, and potentially lead to some longer-term stations below the surface.
What concerns me is this thing bounces around, and you want to get as close to the entrance to a great big hole as you can. I want to do that really carefully. And what I'm thinking is this thing is going to bound towards it. If you get it wrong, it's just going to disappear over the edge.
I think we can direct it carefully towards the edge. And obviously, in the beginning of the mission, you would be a little bit more conservative. You'd be more careful because you don't want to die right away.
Yeah.
Towards the end of the mission, if you know that you won't survive the night, you might be a little more risky, a little more adventurous, and that's okay.
I'm getting Thelma and Louise vibes here. So that, did they make the jump? Did they make the jump?
Right.
Yeah, that bit about surviving the night. See, like most other moonbots, Lunar Leaper would be solar powered and have just 14 Earth days of sunlight to do its work before the sun went down, temperatures dropped below minus 130 Celsius, and the system died in the cold. It's for these reasons that many teams choose to end space missions by going out in style.
Possibly towards the end of the mission, one could think of jumping into that hole.
No.
Whoa! However, no.
All I'm thinking about now is the death of Lunar Leaper. I've heard that it won't make it through the lunar night. Now I've heard that you could possibly jump it into a pit. It's just over there.
It's just over there.
Listen, it's fine. Fine.